I find it best to think of the different summation zones in terms of triangles. So the coupling zone you can think of as an isosceles triangle. As we look here with two loudspeakers, each playing their discrete signals, when they sum together, we maintain an even area of overlap down the center where we have maximum gain. This is illustrating to us that the coupling is happening down the center of the plane. And we can see it to be the case across frequency, which is the reason why that we usually try to keep front of house in the center of the room, so it's in the center of coupling. So even broadband, we're able to achieve maximum gain at any point within our isosceles triangle. Pretty cool. Now, there is going to be a caveat here. This is only the case in the center of the space. So again, this is why we keep front of house in the center of the room, to maximize our coupling for our mixing engineers. Because if we look, when we start moving off center, then we're moving into a more obtuse triangular pattern, and this is where we start to transition into the zone of comb filtering. Everything that I just showed you was straight out of the textbook. Bob already has laid out this exact same example in the chapter. I just wanted to verify it for myself using MapXT, and it's pretty dead on. So just as we should expect now, in the isosceles triangle, or in the center of the room, we're experiencing maximum gain at all frequencies. But as we start moving off center, we begin to see that time shift fall within a period of 0.1 milliseconds, which is the time period for 10K. So it stands to reason that we'll start to experience comb filtering within our higher frequencies. Now, as we move lower down into the spectrum, you can see we start having more of these petals coming out of our polar pattern, and that's because we've now entered into a point where there is a 1 millisecond time offset between our two speakers, and the time period for 1K, that's 1 millisecond. So we're going to start seeing this periodic cycling of summation and cancellation at different frequencies based off of that time offset. Again, this is all stuff we've talked about before, but we got to dust the cobwebs off because that's been, weeks ago, right? And the same trend is true when we talk about lower frequencies, because there is still going to be a fair amount of displacement here. And even though those lower frequencies are large and it can cover a lot of area, that only goes so far. So you will still see comb filtering occurring within your lower frequency content as you move further away in terms of distance. Let's investigate these concepts a little bit more closely, and this material is straight out of the book. So let's say we start off here roughly at the apex of this triangle. We're going to experience maximum addition at all frequencies. And we're going to experience that here as well as here too. As long as we stay within this triangle, we're going to experience coupling. But now what happens if we move from our original spot here to this new location here? Well, for starters, previously where we had our sound sources arriving at equal time and amplitude, we've now created a time offset. to where this speaker is arriving later in time than this speaker. And now maybe a time offset of 0.1 milliseconds might not seem like a lot to you, but it actually is pretty significant. That's enough to cause a lot of comb filtering within our higher frequency content. But it's still going to be manageable. It isn't going to destroy the show. Life will go on. Now, what you'll see is that this trend is going to get a lot worse as we start to move lower in frequency and have greater displacement in time. So here at 1K, we start to see that our polar pattern has all of these petals in it. And that's because that we're experiencing a time offset of 1 millisecond, which is the time period of 1K, right? Now, again though, as long as we stay within the center of our coverage, then we can have all the coupling we want. 6 dB for days. But as we move here, even just the slightest bit off center, we're now experiencing pretty significant comb filtering. However, if we continue to move further off axis, we can see that that comb filter will start to reduce to a certain extent. And even here, we start to gain a little bit more coupling back, and we'll see this cycle repeat itself plenty of times over as we transition through each zone, right? And even at lower frequencies, this trend is going to be still the same. And in some ways, at lower frequencies, it might even be a little bit worse. Now, there isn't necessarily any real difference between here and here because those waveforms are so much larger. But as we move it further from our original point out to say here, that is a great enough time offset from where, again, our speakers were arriving at near equal time, level, and amplitude. Now there's a pretty substantial inequity in time. But we could very well end up in a scenario in which the level offset is so great that the time difference doesn't really matter. And that's some of the complexness of the summation characteristics that individual loudspeakers start to see. And here's the last chart I'm going to hit you with. Again, this is something that would be worthwhile to take notes on because this does a pretty nice job of laying out what the transitions are between the isolation zone, the coupling zone, and the comb filtering zone.